All right, good morning. Hello, everyone. Welcome to the Math 123 exam 3 review for, I believe, the first 8 weeks, if I'm not
Yep.
mistaken. Um, my name is Matanshu Shukla, and I shouldn't put my name on here. I should put tutoring services here because I do represent tutoring services along with Serena here, my colleague. And basically, I'm going to walk you guys through this nonsense, but you guys can see me. I'm sorry, I'm just like fumbling all of this. You guys can see me for math, physics, chemistry, and biology. And I'll let Serena introduce herself.
Hello, everyone. I also do Math 123 and above. I also am a tutor for English. I've been seeing a lot of students for English 111. So if you are taking English 111 and you're needing your half draft reviewed, don't wait. Come see us and we can get that to you very quickly. So thank you for joining us today for math.
Yeah, thank you, Serena. And you guys can call us to schedule tutoring appointments at 260-480-4262. Okay. Give us a call, get a dad joke or two from Jack, um, and we'll take it from there. So, without further ado, let's get started. Number one, a sugar sweet company is going to transport its sugar to market. It will cost $4,500 to rent the truck plus $250 for each ton of sugar transported. The cost, C in dollars. Okay, so as soon as I see this kind of stuff, guys, what I like to do is I like to just underline my information, okay? We know that it will cost $4,500 to rent the trucks, okay? So this has to be a beginning amount, right? No matter what, I have to spend $4,500 to rent the truck. So this is initial, okay, and plus 250 for each. When I see for each, for every, per, things like that, these are clues that this is going to be a slope, okay? And then they tell us a couple of things, like the total cost is going to be represented by the letter C in dollars for transporting N number of tons. So the letter N is going to represent the number of tons of sugar I'm going to be transporting. Okay. And it's going to be given by all of this nonsense right here. C is equal to 4,500 plus 250 N. Any questions about how to interpret this information, how to organize this information, what you're looking for? Everything makes sense. Good. So this tells us C is equal to 4,500 plus 250 N. So we know that this is going to be my cost, and we know that this is going to be my tons. So what is the total cost of transporting 15 tons? What should I do with that 15?
Multiply it by the 250.
We want to multiply it by the 250, right? And ultimately, because they're telling us that this 15 is not just a number, but it's a number that represents tons. So I can plug that in to the letter that represents tons, and I multiply that by 250. Very good. That's going to be 4,500 plus 250 times 15. And what does that give? Times 15. It gives me 3,750. Okay. And then I just add everything, right? So what is 3,750 plus 4,700? Is it 4,700? 4,500. It's 8,250. So what is the total cost? It's 8,250. It's 8,250 bucks.
So the 3,750 is what is this total sum of 4,500 plus 250 times 15?
No,
No,
no. So 250 times 15 is the 3750.
so it's just the 250 times 50.
Correct. Correct. Yep. Very good. Yeah. If at any point it feels like I'm doing witchcraft, you gotta let me know. We can't be doing witchcraft. It's not the 13th yet.
Hmm.
Oh, no, it is the 13th. Oh, snaps. I
Today's
fell
the
into
day to be
one
doing it.
of those. Oh, geez, Louise, Papa Cheese. Okay. All right. Are we good? We're moving on to B. So now they want to know if the total cost is $10,750, how many tons is the company going to be transporting? So this time around, that number represents what? Where am I going to go?
It represents the cost.
It represents the cost. So what should I plug it in for? What letter in my equation represents cost? The C. I should plug it in for C. So I know that C is equal to 4,500 plus 250. And they gave me C, so I'm going to replace the C with 10,750 is equal to 4,500 plus 250 N. Now, and it makes sense because N is the thing that I want to find. N is tons, right? They're asking me how many tons. Any questions? Now, how do I isolate N? Meaning, how do I get N all by itself? And it doesn't matter if you want to put it on the left side or the right side, but walk me through how we're going to get N all by itself. Well, no. Let's look at our equation and let's think about how we're going to get N all by itself first.
So you subtract.
We're going to subtract. What are we going to subtract?
Would it be the 250?
Not, well, so the N is stuck to the 250,
Oh, okay.
right? So I don't necessarily want to get rid of that. I want to get rid of the N or the stuff that's stuck to the N. So maybe I can subtract the 4,500. Okay. And we could have, Jessica, we could have subtracted the 250 N, and I'll walk through that process as well for you, okay? Just so you know that it can be done both ways. So when we do this, we do 10,750 minus 4,500, and we should get 5,250. 5,250 is going to equal what's left on the right side is 250 N. Okay. Any questions so far? Now, how do I get the N all by itself? What do we think? I've got 5,250 is equal to 250 N, and I want to get N all by itself. What am I going to do? What's keeping the N from being by itself? The 250. What is the 250 doing with the N? What math operation is happening between those two things? Yeah, very good, Emodio. So the 250 and the n is being multiplied together.
Okay.
Okay? And so if I want to undo multiplication, I need to divide. You got it. Okay? So n is going to equal 41. So that means that if the cost is 10,000 bucks, it's going to be 21 tons of sugar needs to be transported. Okay. Any questions? We do need to be very good. You know, we need to be confident in solving variables for this exam. That's going to be really helpful. So if we're lacking in confidence between now and the exam and you have time, I would encourage come into the drop-in lab, work with somebody to try and build that confidence up. Okay, it's going to go. It's going to help your, just overall score, I think, on the exam. Okay, so number two. Charmaine received a $90 gift card for a coffee store. She used it in buying some coffee that cost $7.39 per pound. After buying the coffee, she had this much left on her card. How many pounds of coffee did she buy? So hang on a second. Again, organize your information. We received a $90 gift card. This seems to be some sort of a beginning amount, right? My gift card starting balance is 90 bucks. Then they told us that the cost is $7.39 per pound. Again, anytime I see each, per, for every, these are my clues that this is a rate of change, which is a fancy way of saying slope. And anytime I see the slope, I can think to myself, and a starting amount, I can think to myself a linear function. And every single linear function looks like y is equal to mx plus b, where y is some final amount, m is my rate of change or my slope, my x is going to be representative of some independent variable, and b is for beginning, whatever number I'm starting out with. So now let's keep reading. After buying the coffee, she had $60.44 left on her card. That sounds like some ending amount, doesn't it?
Mhm.
So my y is going to get replaced with $60.44. So 60.44 is equal to m. M is slope. Well, my slope is 739 per pound. 739. X is just some variable that I don't know, right?
Mhm.
And plus some beginning amount that I have on my gift card in this particular instance, which is 90 bucks. Okay. Now, this has one small caveat. Okay. When I use my gift card, what's happening to the money?
Decreases?
It decreases, right? So if the cost of coffee is $7.39 per pound, I am losing $7.39 for every pound of coffee that I buy. So this 739 needs to be negative. Okay? And it'll make sense as to why it should be negative. They're saying, well, how many pounds of coffee did she buy? So X has to represent pounds of coffee, right? It has to. If I know that the Y is my balance left in my card, then X has to represent the pounds of coffee that I buy. So, how am I going to get X all by itself? Any ideas?
Is it another one of the things where it's negative 3 point or negative 7.39 times X?
It is times X, but what else is there? So we should let's talk about something real quick, guys. Let's talk about PEMDAS. Do we remember what PEMDAS is? PEMDAS. Please excuse my dear Aunt Sally.
Oh, yeah, yeah.
Okay. Now, P means parentheses. Okay. E means exponents. M means multiplication. D means division. A means addition. And S means subtraction. Okay. When I'm solving for a variable, when I'm isolating a variable that's not on its own, right? That's the only reason I would be isolating it is because it's not by itself. I want to work PEMDAS backwards to undo stuff. Okay. So instead of starting with the P, I'm going to start with the S. And I'm going to ask myself, do I have any explicit subtraction right now? Is anything being explicitly subtracted?
Would it be the $50.44 from $90 or?
No. So I'm asking, is the equation showing us to subtract anything right now? Is it? It's not. It's not showing that to us, right? It's saying that 60.44 is equal to minus 739x plus 90. It's not showing us any subtraction. Is it showing us addition? Yeah, that's exactly right. How do I undo that addition? If money is, yeah, I minus. So I'm going to minus 90 on both sides. And 60 minus 90, or 60.44 minus 90, should give us minus 30.44 is equal to minus 739x. Are we doing okay, guys? Am I doing okay? Am I explaining this okay? Should I switch up my tactics here? Want to read the room a little bit, you know? Okay.
Well, it's not 30, 44, it's 29.56.
Oh, shoot. Nicely done. Thank you. That's what I get for being bold and not using a calculator. 29.56 for sure. Okay. And so now, in order to get x all by itself, I'm going to divide both sides by not x, but the thing that's keeping the x from being by itself, which is the negative $7.39. So we're going to plug this in. 29.56 divided by, shoot, what was it? 739. 739. That gives me 4. So we're saying x is equal to 4. For what? 4 pounds of coffee. Do we have any questions about how the equation was built?
Yes.
What's up?
I I don't know who taught me this, or I think it was the teacher, but the Y, or the total cost, should be the gift card, because that's the total. And then the B, the starting, would have been what's left. And then the M is the $7.39 per pound. And then the X is, that's where you're trying to find how many pounds. So in Alex, if I would have put 90 equals $60.44 plus the 739X, I came up with the same answer. I worked it out on my paper.
Yeah. Yeah.
Uh,
So you exactly. And so it's all about the interpretation of the question. And as long as you're interpreting the signs along with what the words are saying, it's fine. And as long as you're being consistent and you can do that, either way is correct because it gets you to the same place. But for me, the way I saw it is that, hey, I've got some gift card and me spending means I have a negative slope, right? If I was going to plot this on a chart, I would say, well, the x-axis represents pounds of coffee. And they want me to relate pounds of coffee to a balance on a gift card. So if I'm buying more pounds of coffee, I anticipate a trend that looks like this, not one that looks like this.
So that explains the Y is the intercept, or the axis, or the Y is the rise.
Correct.
Or is that
Absolutely.
how you're
Very good. That's exactly right. That's exactly right.
okay?
That's exactly the connection we want to try to make here. Right. Um, let's do the next one and let's think about it in terms of independent and dependent variables. Okay. So if that's okay with everyone, if that's okay, because I really like this engagement here. Okay. The building is open up for interpretation on the equation, but for the most part, as long as you're kind of being very reasonable with what they're telling you things are, it's going to make sense. The math will work itself out. In the one that Haley is describing, I would have divided a positive by a positive, right? But in the one that I'm doing, I did a negative divided by a negative. So we still got a positive value, and we should be able to ask ourselves, does my answer make sense? Well, if X is supposed to represent pounds of coffee, right? I expect that value to be positive. What does it mean to have a negative pound of coffee? That's not a universe I want to live in because I love coffee too much. Okay. So um, I made sure to make it work that way, right? But again, my interpretation was that the cost is this much per pound of coffee, right? So um, I'm thinking about the balance on a gift card being related to pounds of coffee. This is why I wrote mine the way I did. But either way is mathematically correct. So, and then are we struggling with the algebra part of it? Like, okay, so I got it. We're gonna talk more deeper about building the equation, but how about the algebra, solving for the variable? Are we cool on that? Is that problematic? Should I go slower on those parts?
I have no idea.
You have no idea. Jessica, you're like, I guess just do what you're gonna do, math man. Okay. All right. So we're gonna move on to number three here, and I'm gonna ask a lot of questions. Okay, so bear with me, guys. Uh, Owners of a a recreation area are filling a small pond with water. They're adding water at the rate of 32 liters per minute. There are 400 liters in the pond to start. So again, real quick, I know that I see a per, and that means I have a slope. And they're literally telling us that there are 400 liters in the pond to start. That's a beginning amount. Okay. So if they gave me a slope and a beginning amount, I can think to myself linear equation. And every linear equation always looks like some form of y is equal to mx plus b, where y is, let's elaborate, it's not just a final amount, but this is also something that's going to be called your dependent variable. M is still my slope. X is my independent variable. And I'm going to talk about what that means. And B is still my beginning. Okay. I have two things that are called variables in my equation. So I have two variables. What's that mean? It means that there are two things that I'm interested in comparing to each other, seeing how they're related to each other. Okay? One is independent and the other is dependent. So my first thought is when I'm reading this question, it should be what are the two things that I'm interested in relating to each other? Okay? Well, there is water that is in the pond, right? So I'm interested in the water. And I'm interested in relating the water with time. Specifically, when it comes to the water, I'm interested is in the water that's in the pond. Okay? Any questions so far? Everything that I'm saying making sense? Jessica, doing good?
Yeah.
Okay, let me know if you have questions, okay? Okay, so I should ask myself, well, which one is dependent on the other one? So, does water depend on time, or does time depend on water? Let's think about that.
Water is dependent on the time.
Water is dependent on the time. Time doesn't care what it is that you're doing. Time doesn't care if you fill up your pond or don't fill up your pond. It's going to keep going forward, right? That's truth. So we know that water is our dependent variable. And we know that this is being represented by the letter Y. That means that time is our independent, and this is being represented by the X. Okay. Now they're telling us that let W represent the total water. Okay, no big deal. Instead of Y, I'm going to call him W, right? And let T represent the total number of minutes. Well, fine. Instead of X, I'm going to let time represent a capital T, and that's going to be time in minutes. Sure. Now I can put things together. Instead of Y is equal to mx plus b, I really have a W is equal to mt plus b. Any questions? Comments? Concerns?
Yeah. Why is this so important that they do this to us? Why, why do make it so much more confusing? You know,
Yeah.
what's the point of representing the W? Why can't we just call it Y like it's the formula is built?
You know, I agree 100% with you here, Haley. But I encourage you to consider that um, the the level of skill that is needed to successfully complete this course um, does not require you to have this understanding. That's why they give you that extra suggestion that W is this. But because they give you that extra information, and again, it's just a suggestion, right? It's a letter. Listen, I can call a table a chair. Does that mean it's going to stop functioning as a table and start functioning as a chair? No, it doesn't matter what I call something, right? It's going to have the same function that it always does, right? But so this is where the disconnect is in certain parts is that for some individuals, without that being there, there's no way that they were going to even come close to make this equation. However, with others, they can see the clear connection, but then that extra information kind of gets them lost in the sauce. Does that make sense?
Yeah. You're being so kind right now.
Oh, oh, what do you mean? You're being kind.
They're like, you need to get over it because like this is if you get into it further, that I think you're basically saying it's much worse, like in algebra and everything else.
Well, and really, this is why I'm taking the time to explain these connections between the independent variables, between the dependent, because listen, math is supposed to make sense, right? If it doesn't make sense, then it's not really math, okay? It's a language that's built off of logic and reality. If it's not based in logic and reality, it's not math. That's the truth, okay? So, I want to help, not just show you how to like just do this type of problem all of the time. But if they give you any version of this, I want you to be able to think about it, right? What happened? They gave me a slope, which I identified as a rate of change. Anything they described as per, for every, each, right? They gave me some beginning amount. Anytime they gave me that combination of information, I can think to myself, linear equation. And every linear equation always looks like that. Doesn't matter what they decide to call what, as long as I'm aware of what everything should be represented as. Does that make sense?
Yes.
Good, good. And from here, though, so no further questions, we're good. This is not easy stuff, guys. And honestly, let's be real, unless you're furthering your career in math, or doing something, I mean, it is useful. I shouldn't say this, right? This is incredibly useful in your day-to-day life if you know how to use it, okay? But chances are you're using it in your brain without realizing that you're using it, which is, your brain is already doing this stuff without saying y is equal to mx plus b, right? It's not doing that. It's just computing the information, okay? So anyway, I appreciate this conversation. And yeah, anytime you guys, feel comfortable just opening up and let me know, talk to me. That's what I'm hoping I can be a bridge between the content and your class, really. Okay, so let's write stuff down. We have a slope, which is m, and they told us that that slope is 32. So w is equal to 32. T plus some beginning amount, which is 400, right? Then they're saying use this equation to find the total amount of water in 16 minutes. Well, they're telling me to take 16 minutes, figure out what the W or the water is in the pond after 16 minutes. So I'm going to take that 16 minutes and plug it in for T for time. W is equal to 32 times 16 plus 400. So let's do that. 32 times 16 plus 400 and get 912. Okay, and this is 912 what? Monkeys, bananas, horses, zebras. What am I doing? What does that represent?
Liters.
Liters of water, right? Numbers are meaningless unless I give them meaning. Any questions? Any comments? Did this make sense? Do we feel better being able to like organize our information?
Yeah, that really helped getting like visually connecting it with a graph.
Good. Good. Yeah, and we should want to because we can graph this. I can chart it, right? Because here's the next guy. Okay. Number 4, after crossing a bridge, Brian drives at a constant speed. The graph below shows the distance in miles versus time. So I've got distance, right? And I've got miles, or I'm sorry, time in hours. Okay. Use the graph to answer the question. Well, before we jump to the question, again, this is a straight line. Agree, disagree, or not sure, guys. And every line to a mathematician looks like y equals mx plus b. It doesn't matter. I don't care if it's going downhill or just flat. Doesn't matter. Every line looks like this to somebody that is math. Okay? In that line, there's always a slope. Our slope is a rate of change. Okay? So our slope is equal to a rate of change. And in our class, we can absolutely think about rise over run as what the slope is. Yeah?
Yeah,
Yeah?
that's what my teacher said too.
Good.
Go over ride.
Yeah. And what rises? Well, the y-axis rises. What runs? The x-axis runs. So it's some y over x. So when they don't give me words, okay, and they give me a picture, it's kind of actually nicer because I can find the rise over run by looking at it and counting. So if I start at the 0, I know that I went up 25, another 25, which is 50, another 25, which is now 75. So I rose by 75 and I ran by 1. So what is my slope? It's 75 over 1. Now, numbers are meaningless unless I give them meaning. That 75 represents miles. That 1 represents hour. So what is my slope? My slope is 75 miles per hour. Look at that. Any questions? Any
Yeah,
comments?
I,
Yeah, what's up?
can you, okay. So where do, so I don't know. Can you explain this again real
Yeah,
quick?
the whole thing.
Yeah, because I was trying to write down the rise over the run equals
Mm-hmm.
is basically the y.
Uh-huh. Over
This
X.
y over x.
Right,
Okay.
because the
So-
y-axis is going to rise and fall, and the x-axis is going to run left to right.
Okay. So I'm just trying to, what I was trying to do is this formula, the y equals mx plus b.
Uh-huh.
So the y in this formula represents the rise divided by the run.
Very good. Yes, that's exactly right. No, that's not the y. This is the slope. It's the m. It's the rate of change.
Oh, that's the m. Okay.
Yeah.
Okay, so what's the y represent then? What is
Very good. Let's put this together in words. This means that miles, which is the y, is equal to my slope, which is miles per hour, times x, which is the number of hours that I drove, plus b. Well, my starting amount. My starting amount in what? In miles.
which is that the origin would be off.
Exactly. I started from home in this case. Right? So in words, this is what our equation looks like. That if I want to know how many total miles I traveled, I basically take how fast I was going, I multiply that by how long it took me to get there, and I add the number of miles at my origin point, right? So if I was starting from 0, then 0 plus 0. If I was starting with 15 miles, then 15 plus 15. Which it kind of, when you say it like that, it makes intuitive sense, right? Yeah, well, yeah, of course. If I want to know how far I traveled, you know, going on 69, I just take my speed limit and I multiply by however long it was going there, and it's going to tell me how far I traveled, right? It seems very intuitive, but that's what you're doing. Any questions on how to interpret this? Janetta, you doing okay? No questions? Amodia, you doing okay?
Yes.
All right. Okay. So then turns out we can answer all of our questions, right? If I have this information, they can ask me anything they want about this picture, and I'll probably be able to answer it. Okay. How much distance, how much does the distance increase for each hour since Brian crossed the bridge? What do we think here? Did we already figure that out? It would be 75. And what is the slope of the line? Did we figure that out? What is it? It's the 75.
So then we just have to put 75 in.
Yep,
After.
that's the answer. That's the answer. Right? That for each, and the fact that we found a basically, I can say instead of 75 miles per hour, I could say I'm driving 75 miles each hour. And it's the same thing, is it not? Yeah. Good. So now that we've talked about, we know that slope is basically m in our linear equation, and we know that it means rise over run, which we know that the y-axis on a graph is what rises and falls, and we know that the x-axis is what runs on our graph. What specifically about these things is actually telling us that value of a slope? Well, it's really something that's called a change in y over a change in x. Which in a fancy way, we can just say that if I have 2 points, let's say I have a point here, I'll call it P1, and another point here, and I'll call it a P2, right? The connection of these P2 is going to be that from P1 to P2, but every point looks like some X comma Y. Every point, right? Ask anybody that is working with GPS. I always have to have some coordinates, right? If I want to know where I'm going, give me some coordinates, right? If we've ever played Minecraft, what are your coordinates? All right. So what we can also say that P1, since it's X1, Y, X and Y, we can call it X1 comma Y1. And the second point we can call X2 comma Y2, since we want to differentiate the X and Y's from the 2 different points. So now the change in Y is going to be my Y2 minus Y1. And the change in X is going to be always my X2 minus X1. So how is this information translate to a problem like this? Well, I have points. I can just call this P1. I can just call this P2. And we know that every point, let me write that down somewhere. Every point always looks like some X comma Y. Always, no matter what. Okay? Unless if you add more dimensions, you get more letters, but we're not there. Let's stay in our 2-dimensional concept. Okay? So every point looks like this. So I can label these as X comma Y. And if that's P1, I'm going to label this as this is X1, Y1. And if this is P2, I'm going to label this as X2, Y2. Then I plug and chug. How do I find the slope? Well, it's Y2 minus Y1. For me, I labeled it as 5 minus 7 over x2 minus x1. And x2 is minus 7 minus x1, which is a minus 4, minus 4. Don't neglect your negative signs. If you neglect your negative signs, this is going to be incorrect. Okay? But whenever I do see a minus minus, what can I do?
Negative into a positive.
Turn the negatives into a positive. That's right. Sounds like the story of my life. Am I right or am I right? Ha ha ha. Just kidding, but not really. Anyway, okay. 5 minus 7. Yeah, and I don't so I really love that here, Amodia, but I don't know, be careful. So I don't know if they're gonna want a decimal as a slope or if they just want it as a fraction so you can plot it eventually. Okay, so I completely agree with your answer there. We have a minus 2 here, and minus 7 plus 4 is going to be a minus 3, which is minus divided by a minus is a positive. That's going to give us a 2/3, which is approximately 0.67 for sure. Okay, any questions, any comments, any concerns?
I took the practice test and they asked for the fraction.
Oh yeah, for like a slope, they do.
They want the fraction?
They
Okay.
usually-
Good. Yeah, just follow the instructions that they're giving you, but as far as the process is concerned, this is how we're gonna do this. Okay? All right.
I do have one question. If
Yeah, sure.
say just, out of the blue, if then there's a negative on top, so say it was a negative 2 over a 3, a positive 3.
Mhm.
How what do you do with that negative? Do you just keep it?
That's a really good question. So I know that my thing is rise over run. But if I have a negative rise over run, what is a negative rise, Haley?
Well, it's the opposite of a rise. It's
A
actually
fall.
a fall.
Yeah. So actually, a rise over run gives me an uphill line, and we should be reading graphs left to right, whereas a negative rise over run or a fall over run gives us a downhill slope. Cool. So anytime you see a negative slope, you can use your intuition. And you know what? They gave you 2 points here. I would encourage you just make a crude picture. 1 point is minus 4 comma 7. Minus 4 is somewhere over here. 7 is somewhere over here. Okay. Then they gave me a minus 7 comma 5. So minus 7 is even more to the left of minus 4, and 5 is lower than 7. And if I were to connect these dots and then read that left to right, is that uphill? Yes, it is. And my slope should be positive. Does that help answer your question, Haley?
Yes. Thank you.
Okay. Number 6. Oh. Justin is a software salesman. Let Y represent his total pay. So just stop, drop, and underline your information. Y represents his total pay in dollars, okay? Let X represent the number of copies of Math is Fun he sells. So X represents the copies of Math is Fun. Okay? Suppose that X and Y are related by this equation. Y is equal to that, right? So every line looks like Y is equal to MX plus B. What is our M in our case here?
Would that be the 2,500?
Would that be? What is interesting about the M? What do we know about the M? Does it look like it's behaving like it should in our skeleton equation here, how should our m behave? What do we know about our m? It's always going to be multiplied to what? Yeah, always, right? So if it's not being multiplied to the x, is it the m? No. So what is our m? And our b is the beginning.
Be the 20.
Very good. Okay. Now, let's answer this question. What is the change in Justin's total pay for each copy of Math is Fun he sells? What's that sound like? A change in. What represents change in?
$110.
Yes, it's the slope. Very good. I agree. Slope is change. Okay. Then, what is Justin's total pay if he doesn't sell any copies of Math is Fun? The 2,500. If he doesn't sell anything, he still gets paid 2,500 bucks. Shoot, sounds like a deal to me.
Yeah.
Okay, then that's it. Any questions? This one was pretty straightforward. So now we get into something that, now that we've gotten comfortable with linear models and we feel like probably more examples of this would be beneficial, we're going to move on to exponential models and go through that, okay? So really quickly, how do I know if something is an exponential model? It has an exponent, okay, as a variable, okay? If it has an exponent variable, it's exponential. Hands down, every time. Okay? And every exponential model, and they give you like 3 different versions of this on your formula sheet. And don't tell your teacher this, but I really don't like that. They give you 3 different versions. But if you remember this way, it doesn't matter what version you're looking at. You're just going to know. Okay? So every exponential model, for our purposes, is going to look like some balance is equal to some starting amount, or my principal, times, in parentheses, 1 plus or minus some percent rate of change divided by the number of times I compounded that rate, raised to the time times the number of times I compounded. And we're going to talk about this. Okay. This can work for money. This can work for populations. This can work for anything. Anything that has a rate and is compounding that rate. I can do this. Okay. So in letters, this looks like B for balance is equal to P for principal, 1 plus or minus R for rate over N for the number of times that I compound, raised to the T times N. T for time. Okay? The plus tells us that something is growing. The minus tells us that something is decaying. Right? My 401k better have a plus growth rate, right? The minus is like, my pounds of visceral fat better start declining at a very specific rate. Um, okay. Any questions? Comments, concerns? So we want to understand that it's 1 plus or 1 minus something. Whenever I have growth, okay, I'm going to do 1 plus something. If I do 1 plus something, should I have a bigger number than 1 in the parentheses or a smaller number than 1 in the parentheses?
A bigger number than one is growth, and a smaller number than one is decay.
Good. If I'm adding something to 1, I expect it to be more than 1, right? So it's going to be bigger than 1. So when in the parentheses, when this is bigger than 1, it means growth. When this is smaller than 1, it means decay. So when I look at this thing, what is the initial value? P means principal or the beginning amount. It's this guy, $295,300. 295,300. Is this thing growth or decay? Jessica, any ideas? Growth or decay? Decay. How do we know?
Because it's, because the 0.87 is smaller than 1.
Love it. That's perfect. Yes, because the 0.87 is less than 1. Okay. Then what is the percent that it's changing by? Right? So I know that 1 plus rate equals what's in the parentheses. And 1 minus rate is also going to be what's in the parentheses. So notice that this is growth and this is decay. Okay. Over here, if I subtract 1 on both sides, when I have a growth scenario, if I want my rate, I just do whatever's in the parentheses minus 1. Okay, if it's a growth scenario. If it's a decay scenario, I do 1 minus parentheses to get my rate. Okay, if it's a growth scenario, do parentheses minus 1 to get your rate. If it's a decay scenario, do 1 minus what's in the parentheses, and that's going to give you your rate. Any questions about that? Write that down somewhere. If it's growth, do whatever's in the parentheses minus 1 to find the rate. If it's decay, do 1 minus whatever's in the parentheses to get the rate. Any questions?
Doesn't matter which order, because I got a negative.
Yeah, that's why it does matter the order, Haley. Yeah, so pay attention to when you're doing growth, right? Or decay. We're doing decay, so we want to do 1 minus the parentheses.
Now, do I have to, but I wouldn't put, when I turn it into a percentage, I wouldn't put a negative percentage.
Yeah, you can actually always do 1 minus whatever's in the parentheses. Just be mindful of understanding if something is growth, it needs to line up with growth, okay? So for us, we're in decay. We're going to do 1 minus whatever's in the parentheses. That's going to give us our rate. And what's in our parentheses is 0.87. It should give us 13.13%. They want a percent, so we need to multiply this by 100. It's going to be 13%. Okay? Questions, comments, concerns?
So you're not going to put negative the answer is not negative 13%.
Right, because they only want to know by what percent does the value of the house change. The fact that they already asked us that it's decay, they, you know, that's the negative. Does that make sense?
Yeah.
Good questions. You're asking good questions. And these are really good, strong things that if we have foundationally down, I'm hoping that things should be easy breezy. Boy, it'd be devastating for me if I, like you guys came and let me know if something like this happens, right? Like the way I'm showing you, it's just not helpful at all. You got to tell me that stuff. Okay. Because, yeah, it's your time. Okay. Moving right along to number 8. Okay. So at the beginning of the population study, the city had this many people. Each year, the population has grown by this much percent. Let T be the number of years. Let Y represent the population. So I've got a percentage as a rate, and they're telling me that it's growing. So I know that it's an exponential model. And every exponential model for our purposes is always going to look like some balance is going to equal our principal times 1 plus or minus some rate divided by the number of times that it compounds with inside of a year, all being raised to the time times the number of times my thing is going to compound in that year. Always. My principal is always the beginning amount. What is my beginning amount here? 390,000. My rate, do I have a rate?
Would it be a 6.2%?
It would be the 6.2%, but we do want our rates as a decimal. So we're going to need to divide by 100. So that'll give us 0.062. And is this thing growing or decaying? I think it's decaying. I'm sorry, growing. I tricked myself. Okay. So I know it's going to be a plus. Now my n is the number of times that I compound inside of a year. Well, this population is growing 6.2%. Is it every month? Is it once in a year? It's growing by that much? Is it once in every 3 months? What's the answer? How many times a year does it grow by 6.2%?
Each year,
So that means what?
one.
1. Okay, so n is 1, and t is some time. We don't know what t is. We can plug all this stuff in, and they want y to be our our balance, our end amount, right? So when I plug all this in, I get y is equal to my principal, 390K, times, we know that it's 1 plus our rate divided by 1. Well, anything divided by 1 is just itself. So I'm just going to 1 plus the rate. And it's being raised to some time power times 1. But time times 1 is just time. And that's my answer. This is the exponential function. Sometimes they want you to add that, so be careful. Go ahead and add that 1 plus whatever your rate is, if that happens to be the case. Okay. Any questions, comments, concerns about how I organized my information and built the exponential model? Okay. Yeah.
I do have a question.
Yeah.
I- Would it have told us if the rate was going to be divided by 12?
Yeah. Because your clue for that is like it's being compounded monthly.
Okay.
Okay. Or if you're working with money like credit cards and stuff, you're going to deal with something called APRs. Okay. And we just need to know that APRs are annual percentage rates. So we have to divide those by 12 because, right, it's an annual, but we know that we pay our credit card bill every month, right? So that rate is being divided by 12, which means that it's being compounded monthly. Good questions. But yeah, they will tell you, Haley. And so the things that we want to look for are things like annual, which means 1, quarterly, which means 4. There's 4 quarters in a dollar. There's every now and again I've seen a biannual, which means twice a year.
Yeah.
Okay. Then there's a weekly. There's 52 weeks inside of a year. And then there's daily, which we want to use 365 days for that compound number. Okay. So they will tell you that. But good question. Yeah. Okay. Number 9. A laptop computer is purchased for $2,450. After each year, the resale value decreases by 35%. Okay, so I have a decrease by a percentage rate. They gave me some beginning amount, and they want to know what is the resale value after 3 years, right? So again, this is every year this thing is going to decrease by 35%. Yeah, in value, right? So I know that this is a compounded exponential model, which means that balance is equal to the principal times 1 plus or minus rate over n, raised to the time times n. Every time I can always use this function. Okay. The balance is the end amount. I don't know the end amount. They're telling me to find the end amount, right? My principal is my starting amount. That's the 2,400. 1 plus or 1 minus? What do you think?
Minus.
1 minus because it's decreasing. My rate, what's my rate?
235.
The 35 as a decimal, that's 0.35. Now, how many times is this compounding? How many times every year is this decreasing?
3.
One time.
Oh, one time?
Yeah, each year. After each year, yeah. So my n is 1, so it's over 1. Raised to the time, well, time is 3 years. Times 1. So this gives me 2,450. 1 minus 0.35 to the third power. That gives me 672.83. Okay. Any questions?
Can you do number 9 again, please?
I'm sorry?
Can you do number 9 again, please?
Yeah, I can. So I know that this is a compounded interest. I'm sorry, compounded exponential model. Okay. So this is the model that I can do, which is my balance is always equal to my principal times 1 plus or minus my rate divided by the number of times I compound, all being raised to how long times the number of times I compound. So let's organize our information. My beginning amount or my principal is 2,450. It's going to be a minus because it's decreasing. I know that my rate is 35%, which is equal to 0.35. I know my time is equal to 3, and the number of time it compounds is 1. Because each year it only decreases 1 time. It doesn't decrease every month. It doesn't decrease every quarter. It decreases 1 time every year. So when we plug all that in, we get 2,450 times 1 minus 0.35 raised to the third power. And this gives us $672.83.
How do you know right away that this was a compounded exponential question?
Yeah, because my rate of change, that's a really good question, Haley. My rate of change is a percentage, right? So there's going to be a huge difference if I'm increasing by $10 in my bank account every year versus 10% in my bank account every year. Does that make sense?
Yes, I remember him saying that a linear is fixed, a fixed rate, and a percentage is a exponential.
Yeah, and we can make like a simple table to visualize that, right? Let's say I have that checking account where I'm not compounding a percentage a year, but I'm adding $10 in savings every year. So if I at year 0, I started out with $100. At year 1, I added $10. Year 2, I added another $10. Year 3, I added another $10, right? Whereas if I'm compounding by 10%, year 0, I have $100. Year 1, I have $100 plus 10% of that. That is $10. So I do have $110, but year 2, I have 10% of my $110, which is an $11 added. So at year 2, I have $121, right? You can see that this starts diverging. Yeah, year 3, I'm going to add $12.10. So I'm going to have even more than $130. I'm going to have $133.10. Right? So this is the power of compounding. Does this help illustrate what you were?
Yes, that's perfect. That explains that exponential curve that kind of it's like a U, a half a U. It just goes
Very
starts off slow
good.
and then it goes up quick.
Yeah, that's exactly right. This is what an exponential model looks like and a linear model looks like. Very good. Asking really good questions, guys. I really appreciate that. It certainly makes my job more interesting when you guys ask questions like that. Okay. Janetta, does that help? Was that okay that I did that? Did I go too fast?
No, you did good.
All right. All right. Moving on to number 10. So here's the scatter plot, okay? And basically, we are showing the time spent watching TV and the time spent doing homework, all right? So TV time is the x-axis and doing homework is the y-axis. We can see that the more time that's being spent watching TV, the less time that's being spent doing homework. That sounds pretty reasonable to me. Okay, so what is this going to ask us? Well, for the 24 students, as the time spent watching TV increases, the time spent doing homework tends to do what? Well, we just kind of discussed that, right? It decreases, right? For the 24 students, there is blank correlation between time spent watching TV and time spent doing homework. What do we think? Our option should be positive, negative, or no correlation.
Negative.
It's a negative correlation. It's going downhill. Okay. And then using the line of best fit, would you predict, or we would predict, that a student watching 15 hours of TV would do homework for approximately how many hours? So we're going to find 15. Is that 15? Yeah. We're going to find 15 on number of hours watching TV. And we're going to draw a line straight up from it until we get to our best fit line, which is this blue line here. And I'm going to run that across and see how many hours of homework that translates to. And it happens to be 14. Or 15.2. That's the best answer. Positive decrease. I didn't realize that there was a word bank there. Whoops. I thought we were just guessing. I don't know if I agree with that 15.2 hours. Oh, you know what? Yeah, I do. What am I doing here? What am I doing? I'm looking at 17 hours. 15 hours would be here. And draw a line straight up to the best fit. Oh, here we go. Now we're getting there. And yeah, now I would agree with about 15.2 hours. Okay. So that's a scatter plot. Number 11. To be able to go on a trip to South America, Jenny decides to save for 6 years. She opens a savings account with $400. The account pays simple interest at an annual rate of 4%. She doesn't make any more deposits. Okay, there's a difference between simple interest and compound interest. Compound interest, it's doing just that. It's compounding, like the way I illustrated earlier. But simple interest is not compounding. That's why it's simple. Therefore, we're going to treat simple interest as a linear model. And whenever they're talking to us about simple interest, we want to say that interest is equal to principal times rate times time. It's not going to compound. Okay. Principal still means the beginning. How much did she invest? $400. What's the rate? 4%. As a decimal, it's 0.04. Time. How long is she going to save this money for? 6 years. Multiply it all together. 400 times 0.04 times 6 gives me $96. Shoot. Jenny, you need a better savings plan. $496 is what not her interest. I'm sorry. Her interest is $96. So how much total interest? $96. That seems discouraging, and it should. And it should be discouraging to you. Be smart with your money. Okay. Put it in a higher yield, put it in a compounded interest account. All right. So if I earned $96 in interest, what is the total amount? Well, it's whatever I started out with plus my interest. So
400 plus 96.
you got it. So it'll be 496. Okay. Any questions? Comments, concerns? Doing okay still? Good. Okay. Number 12. A bank offers an investment account with an annual interest rate of 1.41% compounded daily. Hey, there's our hint. I have a compounded interest problem. I can just stop reading and just write down to the side some balance. It's going to equal my principal times 1 plus or minus my rate over the number of times I compound, being raised to the time times the number of times I compound. Caitlin invests $3,800. Hey, that sounds like a principal to me, right? Into the account for 5 years. Hey, that sounds like some time to me. Okay. Answer the question. Assume no withdrawals are made. What is her money amount in 5 years? So, well, I know that my rate is 1.41%. It's being compounded daily. So, daily, how many days in a year? $365, Matachu. Exactly. Yes, there's 365 days in 1 year. Okay, let's put it all together. So my principal is $3,800. I'm gonna do 1 plus because I hope I have more money if I'm compounding investment money, right? 0.0141 over 365 raised to the 5 years times 365. And we plug all this in our calculator. So we're going to do 3,800 times 1 plus our rate, which is 0.0141. The number of times that we compound is 365. And I know that I want to save for 5 years, and it's being compounded 365 times a year. I have $4,077. $4,077.56. Okay. Now notice when we were doing simple interest, we got our answer as the interest, right? And we had to add it to our principal to get our total balance. When we're doing compounded interest, our answer is our interest plus whatever our principal is already. So in order to get our interest, we have to subtract, right? So it should be $277.56 is how much interest is earned in that 5 years. Okay. Any questions? Any comments? Any concerns? Did I go too fast?
I think our teacher uses, instead of putting B, I think it uses as an A or a FV.
Sure.
Is that correct?
Sure, that's fine,
Okay.
right?
So
It's
that's
a
like saying FV or A is just the future amount, correct?
exactly. It is some ending amount. Very good. Yeah, as long as you know what that means, Haley, it doesn't matter what letter it's called. It'll be fine. Good. Number 13. To purchase $11,400 worth of restaurant equipment for her business, Ashley made a down payment of $1,400 and took out a business loan for the rest. After 2 years of paying monthly payments of that much, she finally paid off the loan. Okay. So what is the amount? What was the total amount that Ashley ended up paying? Well, if she made $443, right? And she paid that as a monthly payment for 2 years, how do I find out what her total payment was? I'm going to take that 422.22 for 40. Oh my gosh. Sorry. 443.22. I'm going to multiply it by 2 because she did that for 2 years, and times 12 because she did this 12 times a year. So she spent $10,637.28. Okay. Does this include the down payment? No. Right? We need to add $1,400 to this. I get 12,037.28. Right? Good. So this is how much money was paid in total. Right? But how much did she borrow? Well, if she needed $11,400 worth of equipment and she made a down payment of $1,400, she borrowed $10,000. Agree, disagree, or not sure? So if she borrowed only $10,000 and she ended up paying $10,000, 600, $10,637.28, this thing right here, she ended up paying 637.28 in interest. Okay. No compounded interest was needed here. They didn't give me a rate or anything. Okay. Questions? Comments? Concerns?
So. What was for what was the 10,000 for?
Was her loan, right? Because she purchased $11,400 worth of equipment, but she made a down payment of $1,400. So she really only borrowed $10,000. Does that make sense? That's like saying, Jessica, I need $100, but I don't have $100 right now. I'll have it tomorrow, but you have $100 that I could use. I don't have that whole $100. I have $20. If I can give you $20 now, right? So I can borrow the $100, and tomorrow I'll give you back that $100. So not only did you get $100, but you made $20 on it. This is how a bank makes money. Whereas I, in this case, ended up spending money. I ended up paying money to borrow a bigger amount of money. Does that make sense?
I think
This is how finances work. Number 14. So, Lena wants to save money to open a tutoring center. She buys an annuity with a monthly payment of $16 that pays 3% interest compounded monthly. Payments will be made at the end of each month. Find the total value. So for annuities, I think what they want you to do is they want you to be able to figure out what Excel formula to put in. Okay. And that formula for us is going to be some future value. And in this context, it is a future value. And we know that because it's an annuity that's going to tell me that I should have some amount of money in the future, right? So future value, and I start a parentheses, and it's always going to be my rate as a decimal. So this is going to be 0.03. And I divide this interest by however much it compounds. And it's saying that it's compounding monthly. So we know it's being divided by 12. And then I do a comma for a number of payments. Now, my number of payments, I'm making a payment of $16 as a monthly payment. And I'm doing that for 10 years. So in 1 year, I've made 12 payments, and I did that times 10. And how much money did I pay into this annuity? Well, I paid $16 a month. Okay. So let's open up Excel. So here's Excel. Can everybody kind of see what I'm doing here? Good, good, good. Sorry, I'm trying to move this in a good spot. Okay. So equals FV for future value. And our rate is 0.03 divided by 12 because it's being compounded monthly, right? Then we know that we're making this payment 12 times for 10 years, comma, and we're giving away, so minus $16 into that account. So we have $2,235.86 in that annuity. Okay. And I think even though they don't let you use Excel, don't freak out, don't stress out. They're going to have a multiple choice. They're going to ask you to pick the right thing that you would plug into Excel. So while you don't need to use Excel for the exact answer, they will tell you to let them know what they should put into Excel. Does that make sense? Good. Number 15. Kareem borrowed money from an online lending company to invest in rare coins. He took out a personal amortized loan for $26,500 at an interest rate of 7.7%, with monthly payments for a term of 1 year. For each part, do not round any intermediate computations, and round your final answer to the nearest cent. So find the monthly payment. Well, monthly payment on Excel is going to be the equals PMT function. Okay. Just 1 second, guys. I'll be right back. Sorry about that, guys. Thank you. But anyway, picking up where we left off, we are doing the PMT function because we want to find out what the monthly payments are going to be. So finding out what the monthly payments are going to be means that we're going to do the same exact Excel formula, except this time it's going to be our rate divided by n, where it's the number of times it's being compounded still. Depending on how many times I'm going to make my payments, it's for 1 year, so it's 12, comma, and however much money I borrowed. I borrowed 26,500 bucks. So minus, because I borrowed. And let's see what Excel tells us. So we're going to do equals PMT our rate is 0.077 as a percentage. It's being compounded monthly, so it's going to be divided by 12. And we know we're making a payment for 12 months for 1 year. So, comma, 12. And we borrowed $26,500. Okay. So this is what my monthly payment is going to be, 2301.52. So if Kareem pays the monthly payment each month for the full term, find his total amount to repay the loan. Well, it's doing this for 12 months. So let's say equals this thing. What's this thing's times 12? $27,618.23. Then they want to know, what is the interest that was paid? Well, I borrowed 26,500, but I ended up paying 27,618. So what's my interest? My interest will be whatever I paid in total minus however much I borrowed, which was 26,500. So I paid $1,118.23 in interest, which is not terrible, actually. But that's a massive monthly payment. Okay, any questions, any comments, any concerns about how I found all that information? All right, moving right along, number 16. David is taking out an amortized loan for 73,000 bucks to open a small business and is deciding between two offers. Okay. The first one charges 12%, 12.4%, and is an 8-year installment. The other one is 9 years and it's 12.6%. Okay. And they're asking for monthly payments. So we're still going to use our PMT function, which we've already used before. Right? So equals PMT, our interest as a decimal, 0.124 divided by 12, comma, it's for 8 years. So I'm going to make a payment once a month, 12 times a year, and I'm going to multiply that by 8, comma, and I'm borrowing $73,000. Over here, I'm going to do equals PMT, but my rate is now 0.126 divided by 12, and it's going to be 12 times 9, and I'm still borrowing $73,000. Now I'm going to see what the monthly payment differences are. Okay. So I know that for the 12.4% equals PMT 0.124 divided by 12, comma, 12 times 8, comma, minus 1,000. So that one is $1,202.56. What's the other one? PMT 0.126 divided by 12, comma, 12 times 9, comma, 73,000. This one is 1,133. So the 8-year is $1,202.56. The 9-year is 1,133.29. Right? So monthly rate wise, the 9-year is a smaller payment, right? But that doesn't necessarily mean better, because we're going to find that out, right? Suppose David pays the monthly payment each month for the full term. Which lender's small business loan would have the lowest total amount to pay off, and by how much? Which means basically how much, what is, which one has less interest? So this is this monthly payment times 12, because I do that 12 times a year, and this loan year time is 8 years. Okay, so I end up paying $115,000 here. Now, here, I'll take my monthly payment multiplied by 12, and I did this one for 9 years. This one is $122,000. So which loan was better? A was better, right? The one that I had to pay more money monthly, but it was less interest by a significant amount. But by how much? By almost $7,000. Yeah. So 1 year saves me $7,000. Okay. So we know that the bank is the better deal because it's 6,949.79 less. Okay. Any questions? That one was a lot. Any questions? Okay. Number 17. Here we go. Credit cards. So the table below shows the credit card statement for the month of October. Suppose that a credit card company charges 1.65% monthly interest on the unpaid balance. Okay. This is a monthly interest. This does not say annual percentage. If it says annual percentage, we need to divide our interest by 12. But because this is already telling us that it's a monthly interest, we just need to convert this rate to a decimal. Okay, that's all we have to do here. So that's what we're going to do. How much will the interest be? Well, the unpaid from September is this much money. Yeah. So if the unpaid balance in September is that, then we're going to take that amount and we're going to multiply it by the percent for the interest. So 1320.80 times 0.0165. And I get 2179. Yeah, 2179. So how much money is there in interest? 21 bucks and 79 cents. Okay. Then what will Yoko's unpaid balance be on her November 1st statement? So for the November statement, the purchases that are made during October is this. So what I need to do is I need to take my September balance or the end of September, beginning of October balance. I need to add my interest on that balance. I need to add the purchase that I made in October. Which is 105.85. And then she did make a payment in October of 195. So I need to subtract 195.23. Okay. So when I do all of that, 1320.80 plus 21.79 plus 105.85 minus 195.23, I get 1253.21. Is going to be the balance on November 1st. Okay. They did tell us, but will not include any interest on the October balance yet. So we have not even included that 1.65% of interest on this balance. Okay. Any questions? All right. And the last one. Okay. So this is called an amortized loan. And I'm going to give you guys some formulas. So my interest payment is always going to be equal to my balance, my loan balance, multiplied by my rate divided by 12. And the reason why I'm dividing this by 12 is because this is an annual interest, but it's being compounded monthly. Okay. So my loan balance is 163. My loan balance is 163,000 times my rate divided by 12. My rate is 3.4%, which is going to give me 0.034 divided by 12. This gives me $461.83.
Could you show me that Excel formula again real quick?
For the PMT or the one I just did?
The one you just did.
Yep. So I did our our loan amount, which was 160 equals 163,000. And I multiplied it in parentheses with my rate, 0.034 divided by 12. Okay. And we do see that here. And it gives us 461.83. Now they want our principal payment. Well, if I want my principal payment, this is always going to be my monthly payment minus my interest payment. So let's do that. What is my monthly payment? Well, it's this $722.87. Minus my interest payment, 261.04 rounded. Okay. Then what is my new loan balance? Well, my new loan balance will be equal to my old loan balance minus my principal payment. So what was my old loan balance? How about 163,000? Minus my old loan balance. And that's what I get. So it's 162,738.96. 162,738.96. Yep. And then I rinse and repeat. I want to find the interest rate. So what is my interest rate? My interest rate is going to equal my previous loan multiplied by my rate, which is 3.4%. So 0.034 divided by 12, 461.09. Then my principal payment is going to be equals whatever my monthly payment is, 722.87 minus my interest. And it's 261.78. And my new loan balance is always going to equal my old loan balance minus however much I paid in principal. And it should match. Oh, it's off by 1 cent. Okay. Any questions though? Comments, concerns? I'll leave the last line for y'all to do. Follow the formulas. Schedule an appointment. Okay. This exam is kind of challenging. There's a lot of crazy math things that are happening here. Okay. So please schedule an appointment if you need to. Come and see us in the drop-in lab. Let's get things figured out if that needs to happen. But yeah, I'm gonna call this a successful exam review. What do we think?
I think it was awesome.
Haley?
Sorry, I was over by the seafood boil.
No, I was gonna ask about the seafood boil.
What did you ask?
Is everything good? Do you have any questions?
No, everything's good. I just didn't get to this last part.
Mhm.
The only thing is we're not allowed to use Excel. So
Right.
I,
That's why I gave you these formulas.
yes, yep. I should probably write those down real quick.
That's a good plan. That's a good plan. Janetta, we do okay?
Yes.
Good. Amodia?
Yes, I'm good.
Good.